So welcome to this is the Further Maths Support Programme online revision session for OCR Statistics 1. And in this session we're going to be looking at discrete random variables. So first of all, discrete random variables are things that take specific values. They don't need to be integers, although they generally are, but you're only allowed to have, say, a value of 1 or 2, 3. Random variables basically means that they all have an equal chance of a random and equal chance of being selected. So with these things you need to be able to construct probability tables and calculate probabilities, but also you need to work out the expectation, which is similar to the mean, and there is a formula for this, which is this, which we'll see again in a bit more detail later. We also need to work out variance, and again there is a formula for this, which we'll look at in a bit more detail later. And also we need to work out standard deviations as well. Okay, so this is the first part of the question. It goes on to talk about the binomial and things, but the first part of the question is quite valid. So we are given a certain four-sided die, and we're told and defined what x is. So x is the score on each throw, and it's got a probability as below. So the die is labelled as 0, 1, 2, 3, and the probabilities of getting each are given as below. And we're told that the throws are independent. So as I've just shown, the expectation of x is equal to the sum of x times by the probabilities. Now, one sensible thing to do, which some students like to do, is to write these all out of the same denominator, because actually adding fractions is quite quick, and sometimes it's going to make life a lot easier. If it's not possible, don't worry about it, but if it's quite easy to do, it's worth doing. Okay, so to get your method mark, you need to demonstrate in at least 2 cases that you're using this formula. And what I mean by that is you're doing 2 of the correct calculations. So the first calculation is to do 0 times 4/8 plus 1 times 2/8, so you've now triggered your method mark, plus 2 times by 1/8 plus 3 times 1/8. And if you work all of that out, you're going to get a value of 7/8. So that's where your accuracy mark kicks in. Okay, so for variance, I showed you that variance of x is equal to the expectation of the squares minus the square of the expectations. Okay, so to do this, we do need to work out what e of x squared is. So e of x squared is effectively the same thing, but instead of writing x, we're going to do their probabilities. And again, your first method mark is triggered by working out or demonstrating that you're using this correctly. Okay, so that's quite easily done just by applying the formula. So you've now got yourself effectively 1 method mark. And if you work all of that out, that's going to give you 15/8. Okay, so you're going to get a method mark. You're going to get your second method mark in a minute, for now using the fact that the variance of x is equal to the expectation of the squares minus the square of expectations. You don't get a mark for just writing down the formula. We now have to write 15/8 minus 7/8 all squared. So that's now your second method mark. And of course, calculating this out will give you the accuracy mark. If you want to write it as a decimal, you're more than welcome, but there's nothing wrong with leaving it as a fraction in that context. Okay, so 5 nice marks. So the next question, we've got 4 cards numbered 1, 2, 3 and 3, and 2 of the cards are chosen at random without replacement. Okay, we're told again what the random variable x is, and we've got to work this out. So it's the sum of the cards that I'm interested in. We're asked to show the probability of getting a 6 and the probability of getting a score of 4. So we'll do 6 first. Now there's only one way really of getting a score of 6, and that's by getting a 3 and a 3. So if we work this out, we've got to get a 3 on the first card, so that's 2 out of 4, and then because we're doing it without replacement, there's a 1 out of 3 probability of selecting the other 3. So working that out, we get 2/12, which is nicely 1/6. So this is worth 1 mark. That's all you get. Okay, and it's the method here that's the critical thing. So working out getting a score of 4, you need to realize that there are 2 ways only of doing this. Either getting a 1 and a 3, or getting a 3 and a 1. So we can work these out really quite well. So we work these out separately. So it's the probability of getting a 1, which is 1 out of 4, and then a 3, which is 2 out of 3, or getting a 3, and then getting a 1. So if we work those out, that's 2/12 plus 2/12, which is 4/12. Whoops, 4/12, which gives me the third. So this is worth 2 marks, so you need to know where your marks are allocated here. Okay, so your first mark, these are independent B marks, is for basically getting one of these correct, and then either doubling it or adding another one in. So some demonstration that 1 and 3 is different than 3 and 1 is really what they're looking for there. Okay, so that's where your 2 marks come in that question. So now we're asked to write down all of the possible values of x and go from there. So the smallest score that you can have is 3. Okay, because once you've picked the 1, that's kind of it really. So we've got to think about the scores. So I'm going to do a rather big table. Now we've worked some of these out already, so that's fine. So x and the probabilities. Okay, so 1 plus 2 would be the smallest score, 3 would be the smallest score. And that can of course happen in a variety of ways. We've established that we can have a score of 4, and we can see that we can get a score of 5 because 2 plus 3, and of course we know we can get a score of 6. Now we've worked out 6. Probability of getting a 6 is going to be 1/6, and we've worked out 4. So we know that the probability of getting a 4 is going to be 1/3. So the probability of getting a 3, it's either getting a 1 and then a 2, or getting a 2 and then a 1. So again, there are 2 ways of doing that. It's the same probability, so it's the probability of getting a 1 or a 2 times by the probability of getting the other way around. Okay, with a 5, it's the same idea. It's getting a 2 and a 3, or a 3 and a 2. So in this particular case, there are 2 ways of doing it. I'm going to show you another way of doing this one in a minute, but it's getting a 2 and then a 3, or the other way around. Okay, and you can see the probability works in the previous case anyway. So this is going to give me 1/6, 1/3, 1/6. Now what you could have done is done 1 minus all the other probabilities to work that one out as well. That's fine. So there are 4 marks here. So you get 1 mark for having these headers. Okay, you don't need it as a table, but I think it's always a good idea just to write it in as a table directly. In fact, actually, with this we do need the table, but that's that. So you get a method mark for working out this value here. You're going to get another method mark for working out this value. Okay, and then the table itself, or a list, anything like that would be fine. So if you decided to write down, for instance, the probability of x equals 3 is a 1/6, probability of x equals 4 is a 1/3, probability that x equals 5 is a 1/3, and probability of x equals 6 is a 1/6, that would also give you the final accuracy mark, because it's not specifically asking you to write down the probability distribution as a table. Okay. So it then says 2 of the cards are chosen at random without replacement, and we're asked to find E of x and var of x. So again, it's always useful just to have the table at hand. So 3, 4, 5, 6, that's x and its probabilities. So the probability of a 3 was a 1/6, 2/6, 2/6, 1/6. As I described before, it's easier if all your denominators are the same. So again, E of x is equal to the sum of x times by their probabilities. So we can have 3 times 1/6 plus 4 times 2/6 plus 5 times 2/6 plus 6 times 1/6. Okay, so you've now demonstrated, so you've got a method mark, you have demonstrated working out the expectation. And if you work all of that out, you're going to get 9/2. Okay, or, you know, you could equally keep it out of 6. 27 out of 6 would be fine, but you're quite used to sort of correcting and simplifying these. So again, to work out variance, I need the expectation of squares, and it's good to lay these out next to each other, because actually you can see the differences between the formulae as well, which I think is quite important. So if you work these out, and again you've now triggered your method mark because you've demonstrated the use of this formula, and if you work all of those out, you're going to get 21 and 1/6. Okay, or as a top-heavy fraction, that would be fine. So the variance, so that's your method mark there. Your variance of this then is going to be the expectation of x squared minus the expectation of x all squared. So to trigger that second mark, we need to see 21 over 6 minus 9 over 2, or whatever you got actually, because it follows through. That's going to be your method mark, and then if you carry it through, you're going to get 11 over 12, and there's absolutely nothing wrong with that as an answer. So you get A1. Okay, and then finally, you may be asked to work in an algebraic sense. Okay, and this to some extent prevents students from just doing this on a calculator. So we're given a probability distribution of a discrete random variable. It's got two values, 0 and 2, with their associated probabilities. So again, E of x, you take the probability and multiply it by its value, multiplied by its probability, and you can see quite happily, with a bit of simplification, we're going to get 2 minus 2a. So again, you get 1 mark, or leave it factorised, I don't mind, but you get 1 mark for using the formula and 1 mark for getting the expectation. So that's quite pleasant. We're then asked to show that. Now, again, can you treat show that questions as find and then agree with the answer? So to do this, we've already worked out the expectation, so we just need the expectation of squares, which is going to be 0 squared times a plus 2 squared times by 1 minus a. So we can see that the expectation of the squares is going to be 4, 1 minus a. Okay, we can see that quite nicely. And then what we've got to do, again, is the variance of x is equal to the expectation of the squares minus the square of the expectations. Okay, so you get 1 mark for getting that bit out. Your second mark is then for triggering this formula. So we've got 4 lots of 1 minus a minus the mean, which was 2 minus 2a all squared. Okay, so nice juicy bit of algebra here. What are we going to get? 4 minus 4a minus 4 plus 8a minus 4a squared. And if we tidy this up, that's going to give me 4a minus 4a squared, which we can see is going to be 4a 1 minus a, as required. Okay, so that's good. So your second method mark is for using the formula, and your accuracy mark is for getting it out completely. So that's quite nice. Okay, that's the most sensible way of doing that question. So there's a nice algebraic one to do. So again, you can see these are much of a muchness. Please work through them. Please make sure you're showing you're working out, and then you'll be fine with these questions.